Okay, the equation tau equals FR sine theta. That only calculates the magnitude of the torque. Torque is a vector, and we need to be able to figure out which sign it should have, what direction it has. So it's not up or down, or left or right. That doesn't make any sense for torque. Instead, it's a rotation. And so we're going to indicate the rotation. Sorry, that one got a little bit messed up. We're going to indicate the rotation for torque with a little circle like that, with an arrow. And so that's representing that counterclockwise is the positive direction. And that's typically what's used in your book and in my notes. You'll almost always see counterclockwise as the positive direction for torque. So that's one thing that you need to indicate whenever you do a problem. Another thing you need to indicate is the axis of rotation. So if we pick this to be the axis of rotation, then that'll allow us to figure out what direction the torque is for each of the forces. So there's 4 external forces acting on this beam. Okay, it's like a seesaw, and it has a pivot point in the middle, and there are 4 forces. But there's 2 more forces that aren't shown. There's a support right here. Okay, and so there's this triangle is pushing up on the beam. And so if we're drawing a free body diagram, we actually want to get rid of this and replace it with the force. And the force is the normal force. You could call it a force of support or something else, but it's a normal force. And then there's also one more force that we haven't accounted for, and that's the weight of the beam itself. All right, now we've got 6 forces here, and let's go about determining what direction the torque is for each of those 6 forces. Now, for doing this yourself, when you do this on your paper, I strongly encourage you to put your pencil down on the object. And so I'll put a picture of one in here. It's not quite as good as doing it yourself. In fact, you can hold your pencil up to the screen and follow along with me. And so right here where this axis of rotation is, that's where you want to hold the pencil. Okay, so one hand is going to be gripping the pencil right here, and then your other hand is going to be used to apply these forces. And so if we're holding it right here and we push downward at this end, it's going to cause the pencil to move that way, which is a positive rotation. Okay, so that'll cause a positive torque. This force F2, when I push on the pencil and I'm holding it still right here, that's going to cause a negative torque. The normal force, if I push right here, it's not going to rotate at all. So the torque due to the normal force is equal to 0. Here I could have labeled these more specifically. There we go. The same thing for the torque, oops, not the force. The torque due to the weight is also equal to 0 relative to this point. And then we have F3. Okay, and so this is a downward force, just like F1 was a downward force. But look what happens if you hold the pencil right here in the center and you push down. That's going to cause it to go this way and rotate like that, and that is the negative direction. So the torque due to F3 is a negative value. And then the tau, the torque due to F4, if you're pushing here, that's going to cause a positive rotation or a positive torque. Okay? Another thing to keep in mind is that depending on what you pick as the axis of rotation, that could change what the direction of the torque is for a certain force. So, as an example, if we picked our axis of rotation to be over here, then F1 is going to create no torque whatsoever. So in other words, you set your pencil down here, and okay, so that right there is our axis of rotation. You set your pencil on there, you grab it right there where the axis of rotation is, grabbing your pencil. Again, you can hold your pencil right up to the screen, and then you push right here with your finger. Okay, so your finger's right here. There we go. And you push, and that's going to cause a rotation in the positive direction. And so if you remember, F2 created a negative torque in the prior slide when we had the axis of rotation at the center. But now if we put the axis of rotation on the left end, which we are allowed to do, then that means F2 is going to create positive torque. And the amount is actually going to be different as well. And then F1 creates no torque whatsoever in this case, but it did create torque when the axis of rotation was at the center.